All right, this is worksheet 7, arithmetic sequences, and we have covered a lot of this already. This formula should look familiar to everybody. When you have an arithmetic sequence, to find a term, you take the first term plus the difference times the number of terms minus 1. We usually put the D out in front of the parentheses instead of at the back. Okay? This formula will be on the quiz. Under the word arithmetic will be this, so that if you forget, feel uncomfortable, it's there. Okay? An arithmetic sequence has a constant rate of change, it says down here. We talked about this last week. If you want to graph an arithmetic sequence, it will be a line. Term 1, term 2, term 3, term 4. You graph the terms across here. If this sequence was like 5, 10, 15, going up by 5s, be linear. Okay? We're all right? Arithmetic will be linear. It talks about explicit formulas. Yeah, we're not going to worry about it. We already covered that. All right, so you have this notes. The only new thing here is this vocabulary. Arithmetic means are terms between two non-consecutive terms in an arithmetic sequence. If I say find the 3 arithmetic means between the terms 7 and 21, you'd have to find 3 numbers that go in here where you're adding a common difference every time. Okay? We'll do some of those in just a second, but that's an example of what we're going to talk about when it says arithmetic means. All right, this just says find the 38th term. Do you remember how to do this? You do need to know that it's arithmetic because really 3 terms is not enough to figure out a sequence, but they've told us it's arithmetic. So they could have given us 2 terms because we know immediately what's the difference. The difference is positive 2. It's adding 2 every time. So how do we find the 38th term? And 38 minus 1, right? So 2 times 37 added to negative 7. 37, 74, what is it, 60? Everybody okay with that? All right. This is an example with the arithmetic means. It says in the sequence below, if they gave us these 2 terms and these 2 terms, and they said there are 3 arithmetic means missing in between here, and then they found them, okay? We're going to talk about it here. Write an arithmetic sequence with 3 arithmetic means between 3.2 and 4.2. That basically means it's an arithmetic sequence with 3 missing terms. The struggle is to find the right number of differences, guys. I just write out the blanks and then I go, okay, they added the difference once, twice, 3 times, 4 times, right? 3 arithmetic means to get from 3.2 to 4.4, they added the difference 4 times. Is that what it comes out, guys? Can you solve that? Point 3? Okay. Max figured it out right away. He said 0.3. So if we add 0.3, what are the 3 arithmetic means that will go in there? Guys, this is self-checking. If we do this right, we should end up at 4.4, right? That's how we know we did it right. So add 0.3 and we get 3.5. Add 0.3 and we get 3.8. Add 0.3 and we get 4.1. Add 0.3 and we get 4.4. That's how we know we did it right. It turns out the last term. So when it says find three arithmetic means, it means find the three terms of an arithmetic sequence that come between those. Find the 28th term of this sequence. What's the trick here? The difference is what? Yeah, the difference is -2. So we take the first term plus the difference, how many times to get the 28th term? 27 times, yep. So to get a sub 28, you'd take the first term plus the difference, 28 minus 1 times, if you needed to work that all out. Is it -55, guys? Yep. And that's a sub 28. All right, find the first term of the arithmetic sequence for which the 15th term is 30 and the difference is 1.4. We could do this without a formula. I'm just going to write it down for those of you who struggle. The 15th term is the first term plus the difference 15 minus 1 times. So 30 is the first term plus 1.4 14 times. So if we do 14 times 1.4 and subtract from 30, we get back to the first term. (1.4) 14 times is 19.6. So if we subtract that off 30, we will have what the original first term was, which was 10.4. Nothing new so far, right? This one says find the difference. Again, I'll write this out in case somebody needs me to. You guys see if you can figure it out on your own. The 40th term is the first term plus the difference 39 times. And that 40th term is the first term plus the difference 39 times. I got 3.5. Anybody else? Okay. Subtracted 6 divided by 39. How could we put that in our calculator to check? If you wanted to actually see the sequence, do you remember how to type that in? You'd say go to y equals and say the minimum term number is 1. Yeah, we could put in, well, we found that here, let's do it this way. The sequence is the previous term plus 3.5, right? That's what we said the difference was. And the first term had a value, or u sub n min, this would say, sorry, had a value of 6. So if we put that in, then we could scroll down and the 40th term had better come up with this. All right, that was an aside to remind you about the calculator. Guys, less chatting would be great. What is this asking us? This is a weird question. Number. We need to find what term number. 27 is in this term, and I don't know what term number it is. Okay, so it goes -12, and then we're adding 3, so that'd be -9, dot, 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 dot. And then out here somewhere's a 27. Whoops, I can write. 27, we need to figure out what term number that is. Well, if we know this formula, what do we know? This is 27, -12 plus 3 times n minus 1. Okay, you can distribute, simplify. You could just work backwards. I was not distributing, I got 14. So this is the 14th term. There's a couple of those on the question, kind of weird. Asked you to figure out the term number. All right. This is the new stuff, guys. Write an arithmetic sequence that has 3 arithmetic means between 17 and 39. So there are 3 missing terms we have added to get to 39. How many differences have we added, though? 4 differences. Okay? So 17 plus 4 differences got us to 39. If we subtract, I think it's 22, I did it wrong last period, and divided by 4 is 5.5. So let's check if this works. If we add 5.5, we get 22.5. If we add 5.5, we get 23, and 5 is 28. 33.5. 34, and 5 more is 39. Yes, it checks. Okay. Everybody all right? That's arithmetic sequence. This one is kind of painful. Let's see if we've learned anything. What have we learned by doing a couple of those? How do you get out to 16 if you need 7 terms? 7. Yep, I got one too many blanks in here. All right, we added 8 differences. Good job. So -2 plus 8 differences gave us 16. .25 maybe? We can do decimal, I don't care. So -2 plus 2.25 would be 0.25. Plus 2.25 would be 2.5. How am I doing so far? Plus 2.25 would be 4.75. Okay, plus 2.25 would be 7. Then 9.25. Then 11.5. I'm running out of room. Then 13.75. 14, 15, 16. Okay, 1, 2, 3, 4, 5, 6, 7. There's the 7 terms in between there, and that's really messy. Do you need me to rewrite that, guys? Everybody okay? Apologize. All right. The other thing that will be, this is brand new, so please, if you haven't been paying too much attention, this is the sum of a finite arithmetic sequence. Do you remember that the sum, or excuse me, the series part means that there's plus. So that's a finite arithmetic sequence. It's arithmetic because the terms are going up by 2. It's finite because there's exactly 5 terms. It's a series because there's plus. All right? This form will be given on the quiz on Friday. Under the word arithmetic, it will also say the sum of an arithmetic series is the number of terms divided by 2 times the quantity first term plus last term. This one will not be on the quiz because it's really just how to find the last term so that you don't have to plug it back in. I'm not going to do that for you. All right. This is kind of a weird thought, but it says all infinite arithmetic sequences. If you think about that, an arithmetic sequence is going up by a common difference, yes? Is that ever going to be convergent? It could be going down, but it's linear, right? The only way for an arithmetic sequence to be convergent is if the difference was 0. Okay, if it was the sequence was 7, 7, 7, 7, 7, then it would be convergent. Okay, so the sum of an infinite arithmetic sequence, basically there aren't any unless it was a list of numbers. All right, a list, it had a difference of 0. And even then, the sum would approach, yeah, would be infinite. All right. Find the sum of the first 50 terms of this sequence. Again, this is the formula as it's given. I talked about this one other time about how this came about, but you're adding the first term and the last term times the number of terms divided by 2. When they give it to you like this and they give you the last term, they're telling you this term is what? Yeah, this is term 50 and this is term 1. So to find this sum of 50 terms, you just do 50 divided by 2 times 11 plus 158. This is super easy when they give you this kind. And again, the formula will be on the page. Anybody get 4225? All right. This says find the 23rd partial sum. Guys, everybody gets freaked out when they see those words. It just means find the sum of the first 23 terms, okay? That's all that means. But what is tricky about this problem is that we don't know what? We don't know the 23rd term. Well, can we find it? The first term plus the difference. What is the difference, guys? Careful. Negative 11. Everybody all right? It's going down by 11. How many times if we want the 23rd term? 23 minus 1, so 22 times. So 173 and 11 times 22 subtracted negative 69. Anybody get that? So term 23 is negative 69. So to find the sum, we do what? 23 divided by 2 times the first term and the last term. That's it. Make sure you're typing this in so you know how to get it typed in and answer correctly. Anybody? It's not what I have. What? 173 and negative 69 is 104 times 23 divided by 2 is 1196. We're getting like all kinds of different answers, so I hope everybody's typing. If you want, type 23 divided by 2 and then parenthesis 173 plus negative 169. You can type it just like that. Did you figure out what you did, Mika?
Yeah, I actually added it. I guess I'll trust the button really quick.
You're okay. Everybody all right?
Yeah.
All right. Find the 82nd partial sum of this one. Can you try this one on your own, guys? You're going to have to find term 82 first. Everybody good with where I got term 82 up here? Yes, no, negative 10,045.
Yep.
Anybody lost? You guys good? All right, the sum of the first 25, again, by them giving us the last one, they're telling us this is the 25th term. So this is super easy. Anybody get an answer? Nicely done. What about this one? 53rd partial sum. Anybody get 428 for that term?
Oh,
For the last term?
yeah, 428.
$11,660, maybe?
Yep.
All right. Just a couple quick review questions here. If you have a newer calculator, you can do alpha and then window and find the summation notation at choice 2. I don't know what I just did. And then you can fill in all those little boxes and do this question. The rest of us who don't have that feature, again, it's second stat, arrow to the right twice, and choose sum, which is choice 5. Second stat and arrow to the right once, and choose 5, which is sequence. Then you have to put in the sequence. Do they give us the sequence of this problem? (3n plus 1) is the sequence. This one is trickier than most to do by hand. Well, by hand, you'd have to put in a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And add them all up. But to use a formula, this does not start with term 1, so it gets a little wonky and sometimes students get it wrong. So this is a good one to use the sum sequence for, if I can find where I was. Okay. It's 3n plus 1, comma, n, comma, 3 to what? 15? I forgot. Okay. So it should look like this on your screen. Sum sequence, and it doesn't matter if your variable's x, 3x plus 1, comma x, comma 3, comma 15. 364, yes? No? Everybody okay? Can I see what you typed? Does it say go to?
Okay, because there's
Oh.
parentheses in there, right?
Yeah, I think so. Let's try. Getting rid of this parenthesis.
Yeah, okay.
No problem. Anybody else? All right. I just wanted to show you one where you probably want to use the calculator. You can use the calculator on this one too, but this seems kind of, it's the sum of the first 42 terms. This is an explicit formula, right? So we could just do 42 divided by 2. What's the first term? Put in a 1 and you get 2. What's the 42nd term? Put in a 42 and you get 84, yes? So, I don't know, this seems just as easy to me. if I didn't write it so badly. 21 times 86, 1806. Okay. All right. This has been a while. We actually did this. I don't know if you remember doing this when we did matrices. We said ax squared plus bx plus c equals y. And then we had ordered pairs. And for a quadratic formula, you needed at least 3 ordered pairs. For this sequence right here, the first term is 12, so have 1 12. The second term is 20, 2 20. The third term is 30, 3 30, etc. You could pick any of them. Then we put these in for the x and the y. Do you remember that? So we had a times 1 squared plus b times 1 plus c equals 12. A times 2 squared plus b times 2 plus c equals 20. And a times 3 squared plus b times 3 plus c equals 30. And then we went through and put in a matrix that was 1, 1, 1, 12, 4, 2, 1, 20, 9, 3, 1, 30, and we did RREF, and we found the coefficients of A, B, and C. Can I tell you there was an even easier way, and I just didn't bother to tell you at that point? Okay. If we know it is quadratic, you can use the quadratic regression, which is what I'd like you to use today. Okay, so instead of doing that, we'll skip that one and do this one because you have it on your paper, yes? Okay, this is what I want you to do. Go to Stat, Enter. Let's see, I'll use this one. Stat, Enter. And clear out list 1 and list 2. So you go up onto the title and hit clear enter. Don't delete. Is there anybody who does not have a list 1 and 2 because they've deleted them? All right. If this is our sequence of numbers, 8, 16, 26, 38, 52, 68, do you remember how we graph that? What do we have to put in? Yes, this is 6 terms. So in the x column, or the first column, we're going to put 1, 2, 3, 4, 5, 6. And honestly, you could use as few as 3 points to get this if they told you it was quadratic. Then we're going to put in list 2 these values. Okay, and because we know it's quadratic, okay, I should have showed you this before we started, but we're just going to go stat, right arrow. Do you remember this list of things, all the regression? We're going to pick the quadratic one, which is choice 5. And we don't care to store it, we just want to see the equation, so just hit enter till it shows up on your screen. And we got, if I write it down right now, it will say y equals 1x squared plus 5x plus 2. Let me move this out of the way. That's really not the right format, so I want to show you, was 1x squared plus 5x plus 2, okay. What you really should be writing here is a sub n equals 1n squared plus 5n plus 2. It's an explicit formula for a quadratic model. Now, this is what we should have talked about first. I need you to subtract these two numbers, guys. Okay, be careful. Those are not a common difference. Okay? If they were a common difference, this would be what kind of sequence? Arithmetic. Okay? In other words, linear when you graphed it, yes? This is called a second set of differences, and the second set of differences is 2. Everybody see that? So the second set of differences being constant, whatever that constant value is, that's what makes it quadratic. So try this with me, and I'm going to need some proper calculations, guys. 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third, 5 to the third, 6 to the third, 7 to the third. Okay, I got those right. But now I need some subtracting. What's 343 minus 216? If we screw this up like we did last hour, we're just stuck. 216 minus 125. 125 minus 64. 64 minus 27. 27 minus 8. Okay. Now again, I'm going to start at the bottom. 127 minus 91. 91 minus 61. 61 minus 37. 37 minus 19. And now the last set of, so now it took us, this was the first set of differences, the second set of differences, the third set of differences, yes, is finally constant. That's because it's cubic, okay? All right. Let's finish. Application problem. The first year salary of an employee is $34,500. Each year thereafter, her annual salary increases by $750. Is this arithmetic or geometric? It's arithmetic because they're just adding $750, right? In real life, most increases are like a percentage or something, and that would be geometric, right? You're going to get another 6%. I wish. Okay? So if we were to write this, guys, as a recursive sequence, what would you tell me? Do you want to call this term 1 or term 0? Okay, it's what she makes the first year, so I would have called it term 1. Every year after that, she makes the previous year's salary plus $750. Okay? What will her salary be during her 10th year of work? If we were doing it the way I just set it up, we could go to the calculator. Do you remember going to y equals? Well, you're in sequence mode. Do you remember how this goes? You would say I'm going to call the first term term 1, so that goes in the first blank. The second is the formula, u, which is second 7, parenthesis, n minus 1, parenthesis, plus 750. And then the third thing you have to put in if you're using a recursive formula is what the value of that first term was, which was 34,500. Now if we went to the table, we could scroll down and see year 10, she's going to make 41,250. Okay, that's not the best, most efficient way to do that question. I just wanted to remind you of how the calculator worked. How would you have done that question? Anybody? 34,500 plus how many differences is she going to get by year 10? That's what I would have done. Okay. A whole bunch of people got this wrong when I suggested they do it on their own because everybody just found what she made in the 25th year. Is that what this is asking? This wants the sum of 25 terms. if you want to use a formula, okay, if you want to use a formula, you have to find the 25th term. $52,500. Anybody get that? Okay. So then 25 over 2 times the first year plus the 25th year. Anybody get over $1 million? Okay. If I wanted to use some sequence for that problem, I could have done, again, over to sum, then back second stat and over to sequence. Then I would have said my first term was 34,500 plus my difference is 750. And I didn't simplify, so the explicit would just be plus n minus 1. Plus 750 times n minus 1. Where variable is n. What do we want to find? Terms 1 through 25. Yeah, it'll show up on this next screen, I think. If I scroll over here, I have 34,500 plus 750 times n minus 1. Thank you. Got you. I'm like, what did I do? Yep, very good. Thanks, Tyler, for catching that. Comma 1, comma 25. Now, if I did it right, it should be this number. Good catch. All right. So just showing you again, reminding you of those features on the calculator. Does anyone have a question? All right, I'm going to stop the recording, but then